Hello everyone, this is Hemashri pursuing BE Computer Science Engineering at Sri Venkateshwara College of Engineering. Here in this video, we're going to study the course Database Management System. Under this course, we're going to study the topic Introduction to Database Management System. The contents under the topic are Introduction, Components of Database Management System, Data Models, Advantages and Disadvantages, Different Query Languages, Normalization, Security and Backups in Database Management System, and Conclusion. Introduction to Database Management System. A database management system refers to the technology for creating and managing databases. DBMS is a software to organize, that is, create, retrieve, update, and manage data in a database. It provides an organized and structured approach to store and retrieve data, ensuring data integrity and security. The main aim of a database management system is to supply a way to store up and retrieve database information that is both convenient and efficient. By data, we mean known facts that can be recorded and that have embedded meaning. Usually, people use software such as Database 4 or 5, Microsoft Access, or Excel to store data in the form of a database. A datum is a unit of a data, meaningful data combined to form information. Hence, information is interpreted data provided with semantics. MS Access is one of the most common examples of database management software. With the DBMS, businesses can efficiently store and access large amount of data, enabling better decision making and data analysis. Components of a DBMS. First is Data Definition Language (DDL). It defines the database structure and schema. Next is Data Manipulation Language (DML). It performs data operations such as insert, update, delete, and retrieve. Next is Database Engine. It is responsible for processing queries and managing database files. Data models. Data models are divided into three categories. These are conceptual data model, representational data model, physical data model. Conceptual data model. The conceptual data model describes the database at a very high level and is useful to understand the needs or requirements of the database. It is this model that is used in the requirement gathering process, that is, before the database designers start making a particular database. Entity Relationship Model (ER model). It is a high-level data model which is used to define the data and the relationship between them. It is basically a conceptual design of any database which is easy to design the view of data. Components of ER model. Entity. An entity is referred to as real-world object. It can be a name, place, object, class, etc. These are represented by a triangle in an ER diagram. Attributes. An attribute can be defined as the description of the entity. These are represented by ellipse in an ER diagram. It can be age, roll number, or marks for a student. Relationship. Relationships are used to define relations among different entities. Diamonds and rhombus are used to show relationships. Representational data model. This type of data model is used to represent only the logical part of the database and does not represent the physical structure of the database. The representational data model allows us to focus primarily on the design part of the database. Last is physical data model. The physical data model is used to partially implement relation data model. Ultimately, all data in a database is stored physically on a secondary storage devices such as disk and tape. This is stored in the form of files, records, and certain other data structures. It has all the information on the format in which the files are present and the structures of the database, the presence of external data structures, and the relation to each other. Here, we basically save tables in the memory so they can be accessed efficiently. In order to come up with a good physical model, we have to work on the relational model in a better way. Structured query language is used to partially practically implement relational algebra. Advantages of using a DBMS. Data integrity. It enforces rules for maintaining the accuracy and consistency of data. Next is security. It allows for data access control, ensuring only authorized users can view or modify data. Scalability. It can handle large amount of data and support growing database requirements. Efficiency. Optimizes data storage and retrieval, improving overall performance. Disadvantages of DBMS. Cost of hardware and software. This is the first disadvantage of the database management system. This is because for database management system, it is mandatory to have a high-speed processor and also a large size memory. After all, nowadays there is a large amount of data in every field which needs to be stored safely and with security. Complexity. As we all know that nowadays all companies are using the database management system as it fulfills a lot of requirements and also solves the problem. But a problem arises, that is all this functionality has made the database management system an extreme complex software. For the proper requirement of DBMS, it is very important to have a good knowledge of it by the developers, DBA, designers, and also the end users. This is because if any one of them does not acquire proper and complete skills, then this may lead to data loss or database failure. Performance. The traditional file system is written for small organization and for some specific applications, due to which performance is generally very good. But for the small scale firms, DBMS does not give a good performance as its speed is very low. As a result, some applications will not run as fast as they could. Query languages in DBMS. Structured query language. It allows users to manage and manipulate relational database data. The one is MongoDB query language, specific to MongoDB, enabling queries for NoSQL databases. Normalization 1FM, that is first normal form. It eliminates repeating groups and ensures automaticity of data. 2NFM, second normal form, reduces partial dependencies and improves database maintainability. 3NF, third normal form, minimizes transitive dependencies, optimizing the database structure. Security and backups in DBMS. Data encryption protects sensitive information by converting it into a code that can be accessed with a key or password. Regular backups prevents data loss by creating and maintaining duplicate copies of the database at regular intervals. Access control manages user permissions and restricts unauthorized access to the database system. Thank you.